Okay, good. Let's get started. So welcome to today's Bradford seminar. My name is Wei Pan. I'm an assistant professor joined between SPIA and the Annenberg Center for Energy and Environment. It's a great pleasure of mine to introduce today's speaker, Dr. Farid Farrokhi. He is currently an assistant professor at Purdue University in the Department of Economics. He's currently on leave. That's why we can steal him briefly to Princeton for a year. He's now visiting Princeton University in the International Economics section and Department of Economics as the Peter Kennan Fellow and a visiting assistant professor and research scholar. He got his PhD in economics from the Penn State University in 2016, and his research interest is mainly in trade and environment. And that's the reason why he's going to talk with us about can trade policy mitigate climate change, and I definitely look forward to hearing the answer. With that, let's welcome today's speaker.
Of the same title. So let me just start by highlighting a growing concern in academia and also in the domain of policymaking that recent and existing climate agreements, such as the Paris Climate Accord, have failed to deliver a meaningful reduction in global CO2 emissions. And the reason seems to be rooted in the incentive structure of these global agreements, namely the issue of free riding in climate action. The issue is that cutting emissions for each country is costly, but the benefit of that is global. So then it leads to a situation in which, as a country, I want to rely on your costly emission cuts, and you want to do the same with respect to me, and nobody would take sufficient action. So here's a quote from William Nordhaus, his AER 2015 paper. He won the Nobel Prize for his contributions to economics and climate change, and so that's one reason I'm quoting from him, where he says that the fundamental reason for why these agreements failed is the strong incentives for free riding in current international climate agreements. Many countries have an incentive to rely on the emissions reductions of others without taking proportionate domestic abatement. So a number of policy proposals have emerged so that they can address this free riding issue. And among them, an important class of them tries to combine trade policy or border taxes with tools of climate policy like carbon pricing. So let me highlight two of these proposals that have gained particular traction, both in academia and in the domain of policymaking. I'm going to call them Proposal 1 and Proposal 2. Let me pause here, explain to you what they are and how we are going to think about them so that we can evaluate them here. So in Proposal 1, climate-conscious governments, such as governments in the EU, can incorporate what I'm going to call as carbon border taxes in their package of trade and climate policy to influence carbon emissions outside of their national boundaries. So here, for example, you say that your government in the EU, or the collection of governments in the EU, they don't have access to carbon pricing in China. But what they can do as a second best is to tax the carbon content of goods that they are importing from China right at the border. So that's Proposal 1 based on carbon border taxes, but that's not the only way that trade policy could be used in tackling climate objectives. Another way to do that is based on the idea of a climate club, also taken from old writings of Scott Barrett, also William Nordhaus. In that, climate-conscious governments, again, you may think about the EU, also a coalition of the EU and the US together, or any coalition of countries that care about climate change. These governments can form what I may call as a climate club, and in that they want to use their collective trade penalties or trade taxes as a penalty device to incentivize otherwise reluctant governments. So here, trade taxes are going to be used as a penalty device to enforce cooperation of other governments. So these two proposals are kind of similar because both of them try to combine trade taxes with climate policy, but they are different in the way that they do so. So another way to say that is that in Proposal 1, you look at past agreements in global climate action and say, well, they have almost failed. So what I can do is, in fact, the best I can do is a second best by acting unilaterally. So this is the premise here. In proposal 2, you say, but wait a moment, global carbon emissions are just a global issue. It's a global externality. It's not a particular problem of any individual country. It's the problem of the world. So maybe the issue with past agreements is that their design was flawed. Namely, the issue of free riding is just one of the important things there. So maybe what we should do is to stick with multilateralism, but come up with a better design. So that's kind of like the tension between these two. And the goal of my talk today and the paper behind this is to evaluate these two. And for that, you need two things. One is that you want to have a notion of optimality, meaning that within proposal 1 and proposal 2, you can define taxes, and you want to have a sense of what optimal taxes can be. So a notion of optimal taxes in each of these proposals. Second, you want to be quantitative so that you can evaluate these policies to give a sense of quantitative outcomes. And that's all we want to do in a number of steps. First, I'm going to show you a model with no equations. This is a model with many industries and many countries. It models it's very ambitious, but also simple depending on how you look at it. General equilibrium model of world economy. What is key here is that it incorporates a global carbon supply chain so that fossil fuel energy is going to be produced around the world. Maybe it's going to be used domestically or by international trade somewhere else. And every producer or household, when they use fossil fuel energy, they are going to, as a byproduct of their consumption or production, they are going to emit CO2 to the atmosphere, and that creates international climate externality. Then I show you optimal tax formulas so that we can uncover the full potential of carbon border taxes and climate club. Then I'm going to map this model together with optimal tax formulas to data in order to evaluate these two proposals. If I get time at the end, I'll discuss also alternative policy designs. And I also invite you, if you have any questions, I know that that's not necessarily the norm here, but if you have any questions, please feel free to ask. If it's something that we can discuss more toward the end, I'm also happy to do that. So here what I did is just I got rid of all my equations. I'm going to show you like bullet by bullet a high level outline of the model. So there are many countries, and each is endowed by some labor force and some carbon reserves, which you use to produce energy. And there are many industries. For the sake of what matters here is that one of them, K0, is the energy industry or energy extraction industry, and all other industries are final good producers. This is chemicals, electronics, food, whatever. There is international trade in energy and all these final good industries. So every good is going to be traded globally. Markets are perfectly competitive. And then at a high level, think about consumption this way, that everybody's preferences are going to be governed by how much income you have, and that's E here, and a long vector of after-tax prices. This is going to be prices of energy, prices of final goods, after tax as faced by households. And then think about like the structure of demand also this way. Think about two tiers, that in the upper tier, you're going to aggregate a composite consumption of food and a composite consumption of electronics and chemicals and energy, etc. Within each of those, like say agriculture or food, they may come, if we are in the US, as we are, it may come from the US, so it's a domestic purchase. Also, you may import it from every other country. So think about it as these two tiers. And what is key here and in models like this is that products of different industries, there is some pattern of substitutability between them. You cannot substitute them fully, but also to some extent you can do that. Now, the structure of production, or what I'm going to call as energy extraction, distribution, and use around the world, is as follows: that energy industry or energy extraction industry in each country is going to employ labor. Think about a variable input and also exogenously given reserves of fossil fuel to produce energy outputs. When this output of energy is produced, it can be internationally traded. And in every destination country, every country could be an origin, also destination, but once it is a destination, there are energy distributors. And what they do is that they purchase varieties of energy from all around the world, and then they bundle them together to a composite of energy to be sold to households and final good producers. And this is like the way that trade and distribution in energy could be modeled. What matters is that how carbon pricing enters to the system of the world economy. And think about like pre-carbon tax price as the distribution price of energy in each country. Here, this is the market price for a unit of fossil fuel energy, which doesn't care about the externality because of carbon emissions. And that plus the carbon tax the government is going to set equals to the after-tax consumer price of energy in each country, and for each use of it, as that is the case. Then if you are a final good producer, you have a production function in each country and industry that uses labor, as well as this composite of energy at this price that potentially includes the carbon tax if it is non-zero in a country. So you combine labor and this composite of energy to produce final goods, which are themselves going to be traded internationally. And how to think about CO2 emissions here? There is a one-to-one mapping between quantities of energy use and their CO2 emission content, and that's how I'm going to count or calculate CO2 emissions from each country, industry, also households. Then when you aggregate them up to the world level, that's the CO2 emission at the level of the world. So this is pretty much like the model in a nutshell. What is key here, because this is a paper about policy, is to have a clear mind about sources of inefficiencies and how intervention by government with tax instruments can restore efficiency. And thinking about inefficiency here, it's useful to think about it from a unilateral perspective and also a global perspective. And these two are not the same for the reasons I'm going to explain. So from the unilateral perspective of each country indexed by I, there are two sources of inefficiencies. The first one is that if it's really from a unilateral perspective, the government is going to care about the climate damage or the carbon externality to the residents of its own country, not to the residents of all over the world, but just like your own country. So that's one source of inefficiency from a unilateral market. There's also another source of inefficiency, and this might be a term that you are not familiar with, which is terms of trade manipulation intervention. So let me just explain this. So suppose that there are many firms in the US as they are. They cannot or they don't coordinate with each other when they are charging prices in the rest of the world in their exports. So everyone prices individually. The pricing of every firm is like from an individual point of view for a firm. But if they could all come together and coordinate, they could charge a higher price so that they could exercise the market power of the entire US economy. Okay. So it's kind of like a coordination failure in a sense. But again, from a unilateral perspective. Also for consumers, us, when we are importing from the rest of the world, as an individual household, we don't have any bargaining power over the price that we are buying. But if we could come together and coordinate, we could exercise that bargaining power or monopsony power. Okay. So what trade taxes do from a unilateral perspective is that they do that coordination for an entire nation. And this is typically called the terms of trade manipulation, which I'm going to talk about during this talk. Think about it that way, that a country as a whole has a market power vis-a-vis the rest of the world. And these trade taxes are going to exercise that market power. However, from the global perspective, free trade is efficient. No trade tax is going to be efficient. Okay, so that's one difference between unilateral and global. And also from the global perspective, economic activity does not internalize CO2 externality, not for residents of a particular country, but residents of all countries. Okay. So these are sources of inefficiencies from unilateral and global perspective we are going to care about. And the policy instruments that each country is going to be afforded by so that it can restore efficiency from unilateral global perspective are these three or maybe two, depending on how you look at them. One is border taxes, which is import tariffs. When you are importing goods, you can have a trade tax, or export subsidies or export taxes. When you're exporting goods to other countries, you can have a tax or subsidy. In addition to carbon taxes, which I introduced before. So with these three sets of taxes, you can show that governments can restore efficiency. Let me just be a bit more formal here with minimal amount of equations. So I have to define what is the welfare of a country or the objective functions of government here. And one way to think about it, that's the simplest way. You could just generalize it in other ways, but it carries the basic insight that I want to have here, is that think about a country's welfare as two terms. One is indirect utility, which is real consumption of all goods that we have, and that depends on the national income E and the long vector of after-tax prices. So if you don't care about climate damage, that's your welfare, that's the national welfare of a country. However, to the extent that countries are going to care about the climate damage to the residents, we get this extra term. So this C global is the global CO2 emissions in the world, and it's common to everybody because that's the global value. And this delta I is this utility per unit of CO2 emission as perceived by the government of each country. So now the welfare or the objective function of each government combines two things. The first one is real consumption. The other one, or utility from real consumption. The other one is this utility from carbon emissions. And then how about one, or at least one way to think about global welfare, not a country's welfare, is to think about like the aggregate of all welfares, the sort of like the weighted average of them. And so what are the optimal policy problems here, which is kind of like at the core of the analysis here. My goal is to show you optimal policy parameters and variables, and then go back to the evaluation of those proposals that I described earlier. So now optimal policy of the government is going to maximize its national welfare, which was this object, utility from consumption, net of this utility from carbon emissions, subject to all equilibrium relationships in the world. So when you put these taxes, you take into account that the tax that you as a government of a country has set is going to have repercussions for prices and reallocations and quantities all around the world. So you want to maximize your welfare by taking policies as other countries is given. So that's optimal unilateral policy. And optimal global policy, which doesn't exist, and the issue is that this doesn't exist, it's not politically feasible. But we want to use it so that we can have a benchmark to compare or reference to compare, is where, as if there is a central planner in the world, and it maximizes the sum of the welfare of all countries using all instruments of taxes. So these are the definitions of optimal policy, or optimal unilateral policy and optimal global policy. With that, let me show you the formulas or a description of how optimal policy, either unilateral or globally, look like. Here I do have some equations, but I try to convey the intuition behind them. And it kind of just does matter here to have them. First, because they carry some insight about how optimal policy looks like. Also, second, because I'm going to use them in the evaluation of carbon border taxes or the climate club proposal. So this is unilaterally optimal policy. So the government of one country is maximizing the welfare of that country. And it cares about consumption or utility from consumption and this utility from climate damage. So first, domestic carbon taxes are going to be used, and domestic carbon tax is going to be uniform across all uses. So it's uniform within a country, and it equals to the carbon disutility cost to country I. And it kind of, by targeting principle, it should be like that. So the government is targeting the root, the source of the externality here. But how about border taxes? Again, if this is the EU, they don't have access to carbon taxes in China or India or Africa. But what they can do is that they can tax, and optimally what they should do is that they should use their domestic carbon tax and use that here to target the carbon per dollar of import from every country. Okay. So to the extent that you can, as a second best, you mimic your domestic carbon taxing at the border by targeting carbon content of imports. But again, this is not just import tariffs, but also there are export subsidies. Export subsidies, they are a bit more involved. And remember that I told you that there's also the terms of trade, meaning that a country as a whole has a market power vis-a-vis the rest of the world. And the government can kind of do the coordination thing for all firms so that we charge prices, higher prices when we are exporting to use that. Now there are two terms. The first term is this terms of trade driven, by which the government can exercise its market power in international markets. But more relevant to the discussion of carbon taxation is this other term, which we call as a carbon border subsidy. And ultimately what the government should do is to promote exports that are going to compete with carbon intensive foreign varieties in every destination that we are exporting to. So it is a carbon border taxes, but also you need carbon border subsidy. Then once you have this domestic carbon tax, you don't need any import tariff on energy itself, because domestically you are taxing it. But you need to have some export tax, in fact, on energy, which again combines terms of trade and climate motives. I'm not showing you the equation for that because it's a bit just longer and I wanted to avoid that. But the intuition behind export tax or export subsidy on energy itself is that once you have a higher market power vis-a-vis energy importers, you want to use that to effectively impose a higher carbon tax on energy exports. So you want to use, as an energy exporter, to the extent that you care about climate, beyond terms of trade motivations, you want to use that market power to increase carbon taxes, to increase energy prices in the world, so its consumption reduces. So these are the equations in this slide and here for unilaterally optimal policy. Global optimal policy is relatively simple. What the central planner should do, or every country should do in a cooperative first best setting, is to set a carbon price or a carbon tax that is the sum of these utilities. And just compare it to what I had here for a unilaterally optimal carbon tax. For each country I, that was just the carbon disutility cost to that country itself. But globally, that's the sum of those. So every country should care about the externality for the residents of all countries, not the country, not its own country. And all border taxes also globally are suboptimal, so they should be zero. So how I'm going to use these two? The first, circling back to the issue of free riding, one way to think about it, the simplest way, is that, as I just said, carbon pricing unilaterally targets just the disutility to your own country, but globally is the sum, which is bigger. And the incentives to free ride comes from the fact that if you are here, then you have incentives to lower your carbon tax, which is costly for an economy, from this bigger one to this smaller one. So once you are in a cooperative setting, governments that care about their own nation have strong incentives to reduce this. And this is kind of like one way to think about the sentence I quoted earlier from Nordhaus. And how we can think about the two remedies to tackle the free riding issue when we have these optimal policy formulas. One way to use them is to think about a Nash game in which these optimal policy formulas are going to be the best response of each country. And this is going to be a game. Every country is going to play non-cooperatively by using those optimal policy formulas as its best response, and it gives rise to a game. It's a non-cooperative game. The other way to think about it is that we can have a climate club in which a core set of countries are going to form a coalition or a club and use their trade penalties to deter free riding. What are those penalties with respect to these optimal policy formulas? These are penalties that if you use those optimal policy formulas in the club, then those trade taxes or penalties are going to be those that maximize welfare transfers from free riders to climate club members. Okay. So I'll be more specific about this, but let me briefly explain about the results that we've got for carbon border taxes. We have to take this model to data. I'm going to be very brief here. So we have data on international trade, production, CO2 emissions, and taxes on many countries and industries. These are from GTAP database and World Bank carbon pricing dashboard. And the type of exercise, the numbers I'm going to show you, the type of exercise that I'm trying to do here is that we have data. Our data is all for 2014. And our model is going to map to 2014 perfectly. Okay, so our model justifies just the data as an equilibrium for 2014. But at taxes of 2014, right? So that's the baseline equilibrium. Then for any policy scenario that I consider, we compute a counterfactual equilibrium that measures the change from this baseline equilibrium to an optimal policy outcome under the policy that I consider. So that is the type of exercise we are going to do here. And always it starts from 2014 baseline equilibrium. And we have also like a calibration and estimation of model parameters. I'm going to skip them unless you have questions.
Yeah.
Sure.
So in some sense, the relative utility that's achievable under the cooperative and non-cooperative strategies should depend on the curvature of this global value function with respect to emissions, right?
That's right, yes.
So how do you pin down that curvature or discipline that curvature?
You're thinking about, this is a good question, thanks. You're thinking about this delta I?
Yeah, I think the curvature of this VI.
This VI?
With respect to emissions.
So a few parameters are responsible for that curvature, right? So one of them is energy supply elasticity. The other is energy demand elasticity. Third is trade elasticities or demand elasticities for international trade.
Oh, sorry, not the indirect utility, but the curvature of the carbon impacts, just the utility impacts of carbon emissions through climate change.
So then you're talking about delta I in that case, yes, because this is the marginal damage to the welfare. And because it is also, I assume that it's linear, then it's also the damage, not just the marginal, it's the damage at any, right?
In principle, if this was nonlinear and there were curvature, then this.
That's right. If this was a growth model, a linear assumption was not a good assumption. But here it's just, as I'll show you like in a moment, the changes in GDP or this guy is going to be quite limited, so linearity buys that. Also, there is a lot of debate on like what should be the functional form, the right functional form, the climate. Nobody knows that. So I'm happy with like going transparent and simple, but that's a great question. Yeah, thanks. Okay, that discussion also like revealed that there are assumptions and estimations behind what I'm trying to show you. If you have more questions on that, I'm happy to talk about them. But basically, every point I showed you for the model description comes with a parametric assumption about what we do quantitatively here. And we have measured them and estimated them with respect to data. But what was proposal one? Again, here is like governments incorporate carbon border taxes in their package of policy. think about it as a one-shot, non-cooperative Nash game in which governments simultaneously choose their unilaterally optimal policy as a best response, taking policies of other countries as given. Then the data I'm going, or the results I'm going to show you is going to be the outcome of this for a select set of countries so that it's more visible. And I'm showing you here at the end also for the global aggregate outcomes, which I'm going to highlight for the sake of time. And there are two panels, one under non-cooperative outcomes and the other for the globally cooperative or first best. If you look at the first best, and I should say we need also to take a stance on what the social cost of carbon is. And here, social cost of carbon using the recent estimates by energy agencies is 156. And if you change that, you get a different number here. We've done robustness on that. But for the baseline results, the social cost of carbon, or the sum of those delta I's, is $156 per ton of CO2. And on that, for that, you get 41% reduction in global CO2 emissions. If it's a non-cooperative outcome, the game I just defined for you, with the optimal policy formulas, you get 6.5% reduction in CO2 emissions. However, if you are interested in the role of carbon border taxes, this doesn't show you the role of carbon border taxes per se. It shows you two things. The first is that local carbon taxes are at the baseline of 2014 for most countries zero. Even for the EU, it's very minimal. So they are going to raise that to their unilaterally optimal level. And by that, you get a reduction in CO2 emissions. So that's number one effect. Number two effect, or the second effect, is that they are going to have also border taxes or carbon border taxes. And with that, they are also trying to reduce carbon emissions. Okay? And what I'm interested more is in this, to disentangle this second effect. Okay? So to get there, think about another game in which countries go with unilateral carbon pricing, but just domestic carbon pricing with no border taxes at all. This is kind of the similar game, but no border taxes. And under that scenario, you get 5.4% reduction in CO2 emissions. And the difference between these two could be associated, could be attributed to the effect of carbon border taxes, which is very modest. It's just about 1%. And if you compare it to the extra emission you can get when you go from non-cooperative to cooperative, then you can report the results in the following way, that non-cooperative border taxes are capable of replicating only 3% of the CO2 reduction, or the global CO2 emission reduction that is achievable under the first best, which is a very small number, which raises the question of why this is a modest effect. And there are at least three important reasons for that. So let me just explain what these three limiting factors are. The first one is that, and if you look at the data carefully, you see that even without having a model, is that a large share of CO2 emissions are associated with production of goods that rarely cross national borders, meaning that a lot of CO2 emissions are embodied in goods that we produce and consume domestically. They are not traded. For example, trade to GDP ratio is around 10 to 15% in the transportation, metals, and agriculture industry that together account for about half of global CO2 emissions. That's one of the limiting factors. The second one is that there is a carbon leakage through changes in the price of energy. Okay, so one way to see that is here. So EU cares a lot about climate damage. Saudi Arabia and Russia, they don't. As just a reality in 2024, in fact 2014 in our data. So what happens is that the EU is going to decrease its demand for fossil fuel energy. What happens globally is that reduces price of energy. So if you don't have carbon pricing in your country, energy prices globally are now lower, you're going to increase your use of energy. And so you see that like part of what the EU is doing here, or maybe China is doing here, or Japan is doing here, is going to be offset by increases of energy use in other countries that are big producers of energy and have a lower care for climate. So there's this carbon leakage. Third, and this is also important, is that the carbon border tax by design targets the average carbon intensity of industries, right? So what happens is that if you are an individual firm, and there are many firms, think about like chemicals in China. There might be thousands of firms in the chemical industry in China. One individual firm's action or abatement doesn't change the average or aggregate chemical industry carbon intensity of China. And that's what matters for the design of carbon border taxes. So these carbon border taxes are not sufficiently granular to induce firm-level abatement. This is also important. They are like tariffs. They are defined for industries, not firms. I'm going to go, if I have time at the end, I'll return to these points so that to give you some suggestions and more insight about how we can improve on unilateral action. But let me just consider the Climate Club proposal. So the idea is very much inspired by writings of William Nordhaus, but we are formalizing it and bringing this optimal plus quantitative approach to it. So what is that? There are core countries who move first. It's like a sequential game. So think about the EU alone, or maybe EU and US together. Call them core countries. Okay? They move first, and then all other countries are going to play simultaneously afterwards. Okay? So what is the structure or the rules of the game, or rules of membership and non-membership, is that if you are a member, whether you're core or you decide to join as a non-core, you must raise your carbon price from zero or minimal value to a carbon price target, which I'm going to specify in a second, which might be way higher, right? And that's costly for you. If you are a non-member and you decide to stay out, then you stay at your status quo carbon pricing, which is zero or minimal. How about trade taxes? If you are in the club, again, whether you're core, so you move first, or you're non-core, you decided to join, you're going to impose your trade taxes as a penalty device against non-members and go pro-trade, free trade, no taxes with respect to members. So it's going to be free trade among members, but these penalties against non-members. If you are a non-member, you can retaliate with non-cooperative trade taxes. So you're China and you're outside, you can retaliate that, as we saw that the US-China trade war unfolded that way. Okay, what is the key trade-off? If you're a non-core country, like you're China, and the EU has initiated this club, is that by joining the club, you're going to incur production loss due to adopting a higher carbon price, but you're going to escape from this trade war or this members' trade penalty against you. And the equilibrium here is a bit more subtle, is that like these countries who are non-core, so think about like many countries and partition them to those who have joined and those who haven't. You want to understand whether this is an equilibrium of the club or not. To check that, those who are in the club shouldn't have any incentive to leave, and those who are not in the club shouldn't have any incentive to join. And those who moved first, after everybody decided whether they want to join in or stay out, they evaluate whether their commitment to the core membership in the club results in an increase of their national welfare. And if so, then they would say, well, it was worthwhile to commit to that. Here are two considerations for a successful club. How I think about the design of the club. The first is that if you know about Laffer curve, or if you don't know, I explained it here, but it's like a Laffer curve for the climate club. Meaning that if this carbon price target right? It's very low. Everybody will join in because it's just a very small target, right? Everybody would join in, but there is almost no action. But if it's too high, very few will join. Those who will join, they will have like a large action for Climate Club, but very few that would join. And again, overall, you wouldn't have much action. So meaning that a higher carbon price target is going to induce a large emission reduction per member, but it discourages membership, right? So that's one of the considerations. The other is that here, we want to evaluate club success based on not only its effectiveness in cutting global emissions, but also maintaining trade or promoting free trade. In other words, these trade penalties are meant to deter free riding without being exercised in equilibrium. That's what we're primarily interested in. Although I report to you like other equilibria as well. So I'm interested in the maximal carbon price target that supports the inclusive club of all nations as an equilibrium club. That's sort of the type of exercise primarily I'm interested in. And as you might have guessed, that depends on who core members are, because a larger core has more power to enforce cooperation globally. Let me start with a club that is initiated by the coalition of the EU and US as core members. In that case, Club of All Nations can be formed at a maximal target of $53 dollars per ton of CO2. And remember, the social cost of carbon was 156. So you are like a third in the way to get there. And reduction in global CO2 emission, that's 18%. The way we solve this game, which I find it like interesting, so I'm going to report to you, is also informative about the incentive structure in the world. These are the set of countries we have. Some of them are like big regions, like rest of the Middle East, etc. The way we are going to solve this is as follows. Okay, EU and US are there. Then I ask each country whether you join, regardless of what others are doing. They are all outside now. And then I see that countries like Brazil, Canada, Korea, Turkey, and rest of Eurasia, they would join, regardless of others' actions. Right? And these countries typically have strong ties with the EU or US, like Turkey or Canada. And then once these countries are in, now we've got a, also like a reminder for me, we've got a larger club. And at that point, I ask other countries whether they want to join. Now, because now the club is a bit bigger, they can exercise larger trade penalties collectively with respect to those who are outside. So now incentives are higher for other countries to join. And what happens is that you kind of like sweep membership or attract membership from the west to the east. That's kind of like what's happened. And this is also like informative about the gravity structure of trade, which says that countries controlling for the size of countries, those who are closer to each other in terms of geographical distance, trade with each other more. Okay, so the club is the climate club incentive is kind of like using that structure. What if I choose a higher carbon price target? Then a decoupling would happen between what I call as the West, which is the EU, US, and some of their major trade partners, and the East, which is China and some of its major trade partners. So you can do that, but it's kind of risking the possibility of decoupling, which is to say that at least for an exercise to be informative here, is it's more promising if a part of the East could be recruited. We've done a number of different exercises, but because I'm short in time, let me just report to you the Climate Club outcomes, if only the core is the EU and US as I showed you, also EU, US, and China. In that case, the maximal carbon price target could be $90 per ton of CO2, and the reduction in world CO2 emission is 28%. You want to compare it to 1% under non-cooperative outcome and 41% under globally first best outcome. So maybe one way to compare, just to be informative about what we are getting here, is that the coalition of EU, US, China as core membership can induce full participation of all countries in the world at a maximal carbon price target of 90 compared to a social cost of carbon of 156, which kind of replicates around 2/3, this is 28% compared to 41, 2/3 of what is achievable under the globally first best. I have more slides, but maybe I should return to you if you have any questions. And if I get some time, a few minutes, I go over them about some alternative policy designs.
Okay, great. So we get about 13 minutes for questions. Any questions?
Hi, thanks for your work, for presentation. If I understand your work correctly, it's rather static, the optimal
That's right.
policies, and you're making use of market power to determine what the optimal policy of the government would be. How would it change if you take into account time, where if you put on, for example, you levy a tax on export of energy, say OPEC would include the social cost of carbon, wouldn't they lose market power? And then, I mean, others in the market will be still in their shoes, and your policy will probably change if you take into account that.
Yeah, that's right. It's a great question, a great observation. This model was a static, as you said. One way to, it doesn't buy you dynamics, but one way to produce numbers that are of more long-run nature is to estimate your model in a way the elasticities that govern behavior are closer to long-run behavior. And we've done so here. Also, we've compared our model predictions of carbon reductions with a number of dynamic CGE models, and they are very much in line. But the reason we didn't do dynamic here is just because it's not the modeling part, it's the optimal policy part. It gets to be very complicated because, as you said, it opens up the door to all sorts of different considerations. Like, for example, you do today something in anticipation that you do something tomorrow. But also, want to put this in a game, you have to also take into account that what others are going to do, what are their beliefs, and so one step at a time. That's the reason we didn't do it. But you're right, that's one direction, absolutely.
More questions?
Yeah, my question was actually really related to this, but about sort of the role of influence, because if you're thinking over time, you could imagine a country actually wants to be more powerful and have a better economy now because they believe that then they would be able to influence other countries more down the line. So I think that's something, if you would include dynamics, that would probably rise, where it's this trade-off of how much do you sort of scale back your economy now versus later.
Yeah, that's a great comment. Also, like maybe two comments related to that. One is that if you want to think about like dynamics, then a really interesting angle to add is R&D in green technology. And this is not a model about technological investment. And the thing is that the return to R&D comes with uncertainty over time. That's a very interesting question, and I don't know the answer. I can speculate, but I don't want. But the sort of like mechanisms that would be operative there is that, like, again, you can free ride, because if the US is doing it or the EU or China are doing it, then you can wait, right? For them to do, then by the global spillover of technology, you can use that. So that's one thing to do. But you're right. You can also, like, for the climate club exercise, you can imagine that you start with a smaller club, then you try to expand as time goes by. And in fact, if you go back to maybe the closest comparable example of a climate club, which is very hypothetical here and abstract here, is WTO, which started like after the war, Second War, and it was just like several of developed countries, and it was gods, and it worked out for them. Then there were rounds of negotiations, gaining more and more membership, and it took like several decades. And that's, as you said, all about like how the membership would unfold over time. So I totally agree with you.
So part of the, one estimate you had is that in the model, the global first best is a 41% is in line with similar climate economy models?
This is very much in line, but if you add technology, green technology, then it can dramatically change this number. So it's in line with those models that don't have technology.
Oh, so it's like conditional on if we were not able to develop any additional green technology.
Yeah, you should interpret these results. I mean, the only way that you can cut emissions here is to substitute energy or fossil fuel energy with other inputs, right? We've a rather large elasticity for that, which is in line with long-run elasticities in the past decades, but it's within kind of like an umbrella of technology. Yeah, so.
Any other questions? Maybe I can ask one. I think you kind of like proposed two proposals, carbon tax adjustment and the climate club, as two separate, totally different instrument choices. But I feel that in reality, the country might be thinking about both, and
That's right.
we may see a combination of both
That's
there,
right.
and the things about policy interaction will occur. I wonder if you can talk a little bit about that.
Absolutely. Maybe I can take it as an opportunity to talk
course.
about one of these slides here, in fact. And more, I'm going to skip these. I wanted to talk about like CBAM, which is Carbon Border Adjustment Mechanism in the EU, which lies somewhere in between these two. And maybe it's just one way to answer your question, as well as an opportunity for me to make a more general point about a real world example. So what is CBAM? Again, Carbon Border Adjustment Mechanism that the EU started to initiate in October. So it's very, very new. It's kind of similar, but also different compared to these carbon border taxes, back to your point, is that in both cases, you're going to levy taxes on the carbon content of imports. However, CBAM aims to target firm level emissions. And in that, if you are an exporting firm, let's say in Turkey, you're exporting to the EU, and your behavior is consistent with no carbon pricing in Turkey, let's say that's the case, then you have to pay that tariff when you face that tariff or carbon border tax. But if you cut your emissions so that effectively it's as if that you are facing carbon prices in the EU, then you are exempt from those tariffs. So this way, and there is this monitoring of those firms, there's a mechanism for that. In this way, CBAM can potentially target firm level emissions. Okay. It's also contingent on the carbon pricing within a firm, in a sense. Okay. So because carbon border taxes, as the way I defined it, they were not contingent. These are now contingent. And contingency was just like one important aspect of the climate club. Because it was just saying that if you join the club, you're exempted from those penalties in a way, right? So it's kind of like in between. So I just wanted to make some comments about how much success we can expect from the CBAM. And I don't know the answer because it's going to unfold and we are going to monitor that and study that. But some comments. So recall the three factors limiting the efficacy of unilateral carbon border taxes. The first one was that a substantial portion of emissions in the world are embodied in goods that do not cross national borders. Second was that there is carbon leakage through adjustment in price of energy globally. And third was that it wasn't granular enough to target firms. It was targeting industries. So as I just mentioned, CBAM has the potential to target or alleviate this third limitation. And that's a progress that could be a progress. But the extent to which that could be effective is going to depend on the following, I think, is that whether when the CBAM is going to target firm level emissions, whether it's going to be the entire firm that chooses to abate and cut emissions, or going to be, or otherwise going to be only the plant that exports to the EU. Not the entire exports, not the entire sales, but only one plant that is exporting to the EU, because that's the margin EU has directly control on. Okay? And we don't know that because when firms change and update their technology, back to your point, they may do that across all of their production units. Or maybe they don't do that. I don't know the answer, but I think this is important so that we study. How about limitation number 2? I don't think CBAM can do anything about that. Because the moment that the demand for energy reduces by the EU and trade partners, it reduces price of energy globally. And then those countries that are not part of this, the control and reach of this policy are going to increase their use if they want to do so. How about limitation number 1, that you want to induce carbon pricing also for non-tradables? Then this also goes back to your point that it seems to be the case, we yet need to wait and see, that CBAM has the potential to prompt governments in non-EU countries to raise their carbon-wide carbon taxes. But this is an optimistic scenario. There is no reason to believe that that's necessarily the case. But if CBAM or any design of carbon border taxes that has the potential to do that, and the extent to which it does that, then we get closer, in fact, to something closer to a climate club or a beginning of a climate club. So this lies in between of these two proposals.
Thank you.
Sure. Yeah.
Any other questions? So if not, any other questions? Yes, go ahead.
This is also sort of speculating a little bit about dynamic effects. The estimate of the social cost of carbon is
We didn't estimate that. We took it from recent estimates and plugged it here.
Yeah. Do you know if they were using, if they were trying to estimate that based on sort of kilograms cost? Because there is that big issue of, every marginal ton of emissions today has a certain marginal environmental cost today, but then the dynamic costs are going to be much higher.
But the social cost of carbon internalizes. It's kind of the present value of discounted costs over the stream of the cost, right? And from today's perspective.
Sorry. I have a very technical point on this, which is that if you're looking at the static equilibrium, then the social cost of carbon is not going to discount the long-term future warming that occurs from the emission, because the new static equilibrium is already going to be at that higher level.
That's right. I mean, that's maybe the kind of trick we use to make that simple by this linear assumption and that delta parameter.
But what I'm saying is that the social cost of carbon in a model where you're doing comparative statics should be much higher than the social cost of carbon that you are taking from a dynamic model. Because in a dynamic model, the social price of carbon is going to be discounting the far future impacts of carbon emissions. Whereas when you're doing comparative statics, the social cost of carbon is going to immediately realize the higher cost of carbon, and so you should not be doing the long-term discounting.
Yeah, I hear what you're saying, and it's an interesting point, as you said, also a technical point. There is a gap between dynamic models and static models, and you can make different assumptions as how you want to fill that gap. And at the end, what we did it was just to say that, okay, this is our benchmark. Then I'm going to show you all these results under different scenarios for social cost of carbon. If you think it is 300, or if you think it's 50, I'm going to show you what would happen under those cases.
Right, because of
Yeah.
time, let's give Dr. Farrokhi another round of
Thank you.
applause.
Thank you very much.